So our solution to this switching loop is spanning tree. So spanning tree is that mechanism that helps us to prevent the loop. And so we saw last week that before spanning tree can take effect, or we saw how spanning tree works. We said before a particular port will be blocked, what happens is that the three devices, so switch A, B, and C, will decide which of the devices will be their leader. And so the concept of root bridge. So root bridge is just that switch within the loop that helps us to do it's just one switch within the topology that helps us to decide which device will be the middle device. And so in order for us to select a root bridge, we want to look at the device that has the lowest bridge ID. And we said the bridge ID for a switch is made up of the priority number against the MAC address of the device. And so we also saw that the priority number is by default is going to be 32768. And the MAC address is just the MAC address of the device, assuming switch A's MAC address is A000. So that's going to be the bridge ID. Assuming this switch B's MAC address is BA00 or something, and then we want to find a bridge ID by Cisco's principle, because we start with the default. So we'll have the default priority number 32768, and then the MAC address BA00. Same thing applies here, 32768, and then the MAC address, assuming this is 6CC01 or something, CC01. Now, these are the bridge IDs. In order for us to determine who becomes the root bridge, we need to look at which of the devices has the lowest bridge ID. And so that device will become the lowest, will become the root bridge. By default, as I mentioned, they will all have the first part being the same. And so this is the same as this one and as this one. And so if we just looking at the first part, we cannot make a determination as to who becomes the root bridge. We have to take it one step further by looking at MAC addresses. And so this is A, this is B, and this is C. Now, what we have here, A, B, and C are hexadecimal numbers. So basically in hexadecimal, so that's base 16, we start counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's no concept of 10. There's A, B, C, D, E, and F. So technically A is smaller than B. So because A is like 10, B is 11, C is 12, this is 13, this is 14, and this is 15. And so among the three devices, we can clearly see that A is smaller than B and B is smaller than C. So from our logic, then we can say that the root bridge for this network is this one.